Hello and welcome to the third video of Scan DRC series. I'm Akanksha Pushkar from Tessent Technology Enablement team at Siemens EDA. In this video, we will build on our earlier discussion and take a closer look at the S1 Scan DRC and explore how this check helps strengthen overall scan design implementation. So let's begin with the S1 violation. What is S1 violation? Scannability rule S1 checks all the clock inputs including set and reset of each scannable non-scan memory element to ensure that these inputs can be turned off. This rule ensures that non-scan element that may be converted to scan element can be controlled to hold their current data. When is S1 reported? S1 is reported when the tool transitions from setup mode to analysis mode during Scan DRC checks. This report includes the pick path and gate ID of the flop with the violation. For a scan segment, it reports the segment name instead. Significance of S1 is by ensuring that clock, set, and reset inputs can be turned off. The S1 rule helps maintain the integrity of the data stored in these elements during the scan operation. This is crucial for improving the design testability. S1 can occur in this context and it is treated as an error. But for S1, handling can be changed to warning using command set DRC handling S1 warning. Possible causes of this DRC violations are uncontrollable clock and resets, architectural constraints leading to issues in set and reset or clocks, incorrect clock gating. Next, let's take a look at the S1 violation and walk through how it is reported and resolved. After the initial design setup, the first step is to run the design rule checks using the set system mode analysis or check design rule command. Once executed, the tool identifies all the S1 violations typically reported as unstable non-scan cells when the clocks are turned off. The second step is to examine this violation in more detail. The S1 report highlights the exact design hierarchy where the violation is detected. To analyze this further, we use the Analyze DRC Violation command, which opens the visualizer window and automatically filters the view to show only S1 specific violation. This targeted visualization helps in understanding the root cause and simplifies the debugging process. To resolve this S1 violation, we need to update the original design. In this example, we load a corrected version of the design where the S1 reset DRC issue has been fixed by ORing internally generated uncontrolled reset source flop with an externally controllable test reset pin. This external reset pin is constrained such that internally generated uncontrolled reset source do not propagate to this flop. With the modification in place, the reset becomes controllable, addressing the root cause of the violation. Once the updated design is ready, we elaborate it again using the set current design command and apply the required pin constraints. After that, we check for the DRC rules. Finally, we review the updated results in the visualizer window where we can clearly see how our design fix has removed the S1 violation and restored proper reset control. This comparison highlights the design before and after resolving S1 violation. In the first view, we see unstable non-scan cells caused by uncontrollable clock behavior when the clocks are turned off. In the second view, after applying the design fix, the S1 violation is cleared and proper reset control is restored, confirming that the updated logic is now fully test ready. This brings me to the end of the third video of the Scan DRC series. For any queries, please contact me at the email address provided. We will continue with more Scan DRCs in the upcoming videos. Thank you.